Index laws, raising to a power. The zero power comes up often. We've already seen that a power of 1 is just the base number itself. If you have a look at this little example here, this will give us a zero power because index law 2, dividing by numbers of the same base, says that I subtract the powers, so that will quite clearly be 3 to the power 0. But if I wrote this as 3 to the power 2 over 3 to the power of 2, which I can do, I know very well that anything divided by itself is 1. So this is quite clearly 1. And since these are equal, it follows that this 3 to the power 0 must be 1. What this is saying is an example of the zero power law, that anything raised to the power 0 is 1, any non-zero number. So if we're asked to simplify or to evaluate, here I've got 3 to the power 0, which is 1. Here I have 3 times x to the power of 0. This is 3 times x to the power 0 is 1. Remember, order of operations says we'd do our powers before we do our multiplication, so I evaluate this to 1, and 3 times 1 is 3. Sorry about working across the page. We can think of this in two different ways. We'll learn about what to do when I've got a power of a product next lesson or later. But this whole thing is to the power of 0, so this whole thing here is 1. Whereas remember, I separated this out to make it a little bit easier. I could have written this as 3x to the power of 0, and you can see quite clearly that that will be 3 times x to the power of 0. The only part that is to the 0 power here is the x, whereas here, because it's in brackets, it's all to the 0 power. These two illustrate the difference. This one without brackets, this one, without and with. Everything in the bracket to the power 0 means that this is 1 times everything in the bracket, power 0 is 1, so this equals 1. Here, this is 4 times 1, which is 4, times 8 times x times 1, which is 8x. So I've got 32x here, a very different result when you've got brackets and when you don't with the 0 power. We also need to be able to raise a power to a power, x squared to the power 3. As always, we'll look at expanding that out to see what we get. This is x squared times x squared times x squared, as we know. And this is now law 1, multiplying indices of the same base. And we know we add these, that's x to the power 6. Now remember, multiplication is just repeated addition. This is 3 lots of 2. 2 plus 2 plus 2 is 6. So you can see that our shortcut when I have a power raised to a power is to multiply the indices. And in algebra there, a to the m to the power n equals a to the power of m times n. That's our law in algebra. So if I'm asked to simplify these, leaving them in index form, a power of a power means I'll multiply the indices. This is 4 to the power of 2 times 3 is 6. An algebraic question, x to the power of 3 times 4 is 12. Now there is an interesting type of question we get with this where they ask us for simplest index form. And what we have to do with these questions is recognize that 36 could be written as a power itself. 36 is 6 squared. So in brackets there, I'm going to change 36 to 6 squared, but there's still that squared part of the question. 36 is 6 squared, but I'm squaring 36, so I'm squaring 6 squared. And simplest index form gets me down to 6 to the power 4.